Hello, this is Mr. Collier, and today we're looking at the chi-square test for independence. Okay, this is the Greek letter chi, it's not an X. So basically, I'm going to go through this brief example and then do another example. Let's take a look at this table. This is 3 different classes of teachers who teach how to drive. And there's different pass rates for each teacher. So for Mr. A, he's got 28 students pass, 20 fail. And for Miss B, we have 38 students pass and 10 fail. But you can see that there's 48 students in both classes. So it looks like more students pass in Miss B's class than in Mr. A's class. Okay, so basically a chi-square test will test whether or not that difference is significant, whether or not the pass rate is independent of the teacher. Okay, so that's why it's called the test for independence. So when you're doing these tests, and when you're doing any kind of statistical test, we often have a null hypothesis. So this H naught, this little H with a subscript 0, is called the null hypothesis, and it's always that the two things are independent. So you start by assuming that the pass rate is independent of the examiner who conducts the test. Okay? So we always assume that they're independent, and the alternative hypothesis, or H sub 1, is that they are dependent. So basically we assume that they're independent, and then we gather evidence to prove otherwise. Okay? So we know that if they are independent, these numbers should be closer to the same, right? So what should that number be? So we call those the expected frequencies. Okay, so when we calculate that, here are the expected frequencies. If there was no difference between Mr. A and Mr. B, then you should have the number of pass should be 32.5 for both of them, and the number of fails should be 15.5. So that's done with this calculation: row total times column total divided by the total of everything, right? Okay, notice that these ratios are all the same. They're the same as the ratio of the total number of fails to the total number of passes, right? Anyway, so that's how you calculate it. You calculate the expected frequency for each one of these like that, and I'll show you an example. And then you compare. So here we have the observed frequencies, what actually happened, and what should happen if they're independent. And notice that Mr. A should be a little bit more, and Mr. B should be a little bit less. And the chi-square test tells you whether or not those differences are significant or not. The rest of the test is kind of complicated, and it is, to understand it, you need to understand some college level math. But we are going to use the chi-square test for independence, but it's going to be pretty hard to understand where some of these statistics are coming from. But we're still going to be able to use it, and we're going to use our calculator to do these things. Okay, first let's look at this example. All right, we got types of dog food and breeds of dog. There's 4 breeds of dog here, and there's 3 types of food. Okay, and these are the totals of the rows and the totals of the columns. And we're going to do a chi-square test for independence here. Okay, so firstly, state the null hypothesis and the alternative hypothesis. So this is always that they're independent. So dog breed and favorite food or favorite flavor are independent. Okay, so always write that. And for the alternative hypothesis, basically the same thing, but dependent. Okay, so next write down the table of expected frequencies. So if we were to do the expected frequencies, let's scroll down a bit. Let's make a table. Actually, let me make it like this. We've got beef, chicken, lamb. We got boxer, Labrador, poodle, collie. Now the expected frequencies, let's just do one by hand, then I'll show you how to use your calculator for the rest. The expected frequency. So expected frequency, just this number right here, you have to do this calculation. The row total times the column total divided by the total of everything. So you do 28 times 50 divided by 120, and do that in your calculator. You will get 11.7. Okay, so now we're going to calculate the rest of it using our calculator, and then I'll show you how to do the rest of the chi-square test for independence. Okay, so I'll show you how to type this in your calculator and continue with the test. So we need to type this into, actually don't go into statistics and put it into the table, you have to go to matrix. Okay, matrix is right there in blue, so I'll go to second matrix and go over to edit. And this is a 4 by 2 matrix because there's 4 rows and 3 columns. So we have to do 4 by 3. And then we just type in these numbers. So we've got 14, 6, 8, 17, 11, 10, 13, 8, 14, and 6, 5, 8. Do not type in the totals. It'll calculate all that for you. And then I'll go and go ahead and go to do the chi-squared calculations. Let me quit out of here. Chi-squared is under statistics and under tests. Chi-squared is down further. I believe there's 2 chi-squared things down here, 2 chi-square options. But you want the first one, the chi-square test, not the GOF. So we picked that, and this should be A and B. It should be by default. So just click on this, and we get some of these things which I'll talk about a bit later. But now what we have is, if you go back to matrix and you go to B, it will put the expected values in B. So remember, the expected values are what we expect to happen if they're independent. So if these two things are totally independent, then yeah, you get 11.7 here, which is what we had from before. Okay, so we have them all there. You can press the arrow over to get the rest of the numbers. So here are the expected values. The thing about the chi-square test for independence is we actually don't want any of the expected frequencies to be less than 5, or we say the test is not very valid. We don't have enough information. So this one's less than 5, so the test is not valid. That's why we're going to combine the results for collie and poodle so that the expected values are all greater than 5, and we're going to write down the new set of observed values. So we're going to combine these two. Let me erase some of this stuff here. Okay, so we'll combine those into one category. So that's going to be actually 19. So 19 poodles and collies. This is 13. This is 22. And this is the total, so we don't need to work with those. Okay, so what we have now is actually we have a 3 by 3 grid. Okay, it's three rows, 3 columns. So we can go back to the calculator. We can go to second matrix and go over to edit. Okay, let's change that to 3 by 3. And let's change this last row to be 19, 13, and what is that, 22, right? Okay, so now we go back to statistics, calculate, we'll go down to C, chi-squared test, make sure that says A and B there. Okay, so we've got all this information, but now we go back to matrix, and we go to B, and we can see the new expected values. Oh, let me press enter. And now none of them are less than 5, so we can proceed. Okay, so let's actually look at the rest of the questions here now. Well, we can write down the value yourself. Degrees of freedom. Let me briefly explain that. Your calculator shows you what that is. But basically, the degrees of freedom will just circle this part of the grid. Okay, just exclude the bottom row and the bottom and the rightmost column. And the degrees of freedom is 4, because if we know any of these other numbers here on the outside, we can figure out all the totals and figure out how much is in everything. Okay, so basically these are free to vary, and that's where the word degrees of freedom comes from. Anyway, you need to know what the degrees of freedom is for the test, so that's how you do it. Your calculator also spits it out. There's a formula, and it kind of makes sense. It's just the number of rows minus 1 times the number of columns minus 1, because you basically subtract the 1 row, 1 column, and that's how much is left. In this case, it's 2 times 2, which is 4. So that's the number of degrees of freedom. The chi-squared test, that's the number that comes out of your calculator, so we'll write it as chi-squared calculated. And we have a p-value as well that comes out of the calculator, which I'll show you in a second. Okay, so on the calculator, let's go back to that chi-squared test. So we go to statistics, tests, we go down to C, and calculate, and we got degrees of freedom is 4 there. Chi-squared is 3.14, that's 3.14, and the p-value is 0.536. Okay, so next write down the critical value. There should be an is there. Critical value chi-squared at 5% significance level. That 5% means the significance level is 5%. Okay, so basically for that, you just look up this table that you have in your booklet, and if you go across from 4 degrees of freedom, that's why the degrees of freedom is important. We have to figure out which row to look at in this table. We go across to 5% significance level, and we have 9.49. So that's that value, 9.49. And then the last step is comment on a result. That's basically your conclusion. Do we reject the null hypothesis or accept it? And we have a mnemonic for that, which you should memorize. And it goes like this: if chi is high or p is low, reject HO. Okay, which is the null hypothesis. Okay, so we reject the null hypothesis if chi is high or p is low. And the chi that we've calculated is 3.14. So our calculated chi-square value is 3.14. That is not high because it's lower. It's lower than the critical value. So that's what we mean by that. So it's not high, and the p-value is 0.536. All right, which is actually bigger than 5, the significance level, which is 5%. Okay, so it's neither of these things. Chi is not high and p is not low, so we do not reject HO. Therefore, we do not reject HO, which means that dog breed and favorite flavor are dependent. Okay, so not all dogs like the same flavors. There's a difference depending on the breed.